So in addition to the line and surface integrals which we looked at already, we will also come across volume integrals. And volume integrals are essentially is the integral of some scalar function t over the infinitesimal volume element. The infinitesimal volume element in Cartesian coordinates is given by the product of dx, dy, dz. Now, we may come across problems where we have to determine the volume integral of vector functions. However, since the unit vectors are constant, what this means is we can bring them outside the integral. So as we can see here, we can bring our x hat, our y hat, and our z hat outside the integral and then just carry on and do our volume integral. Now let's just look at a problem where we want to calculate the volume integral of t equal to x, y, z squared over the prism. What we must first do is determine how x, y, and z vary. We can see that x is going to have some dependence on y. For when y is equal to 0, x is going to be equal to 1. And when y is equal to 1, x is going to be equal to 0. So what we know is that x goes from 0 to 1 minus y. Y goes from 0 to 1. And for z, it goes from 0 to 3. Now let's just write out our volume integral. So we've got the integral t d tau, which should be equal to, and we look at the three integrals in turn. So look, for z first, goes from 0 to 3. And this is for z squared. For y, integral goes from 0 to 1 for y, and for x, it goes from 0 to 1 minus y. dx, dy, dz. What we can do is you can just work out these integrals in turn. So what we're going to get is we're going to have for x be 0 to 3 of z squared. And when we do the x integral, we're going to be left with x squared over 2. So I'm going to bring that half to the outside. And inside here, we're going to be doing the integral from 0 to 1 for y into 1 minus y should be squared dy dz. So now when we work this out and we do the integrals, we will have a half. The integral of z squared dz is going to result in z cubed over 3, which is going to give us 9. And the integral for y, when we work it out, is going to result in 1 over 12. And so our answer comes down to 9 over 24, which we have is 3 over 8. Okay, so that completes the line, surface, and volume integrals.